Okay, the first question asks us, what is the vertex for the quadratic function y equals negative 3x plus 12 squared minus 20? All right, so first thing is asking for the vertex. Looking at the graph here, we know the vertex is going to be where the graph curves. So that would be at 1.5 and 4.5. So x value is 1.5, y value is 4.5. Oh, my mistake, guys. I was thinking this graph had to do with this function here, but the graph is for the B, part B, and this quadratic doesn't have anything to do with that graph there. So looking at the quadratic function, here's our h, here's our k. We know vertex is hk. So our vertex here would be negative 12, negative 20. Now moving on, we know what the vertex is for the second one, 1.5, 4.5. Now, do we have a minimum or a maximum here? A maximum. So we'll circle max and we'll say y equals 4.5. Our zeros, those are the x-intercepts. Yeah, so we have 0, 0, and 3, 0. Thank you. Our axis of symmetry is always going to be the y value of the vertex. So we'll say x equals, I'm sorry, the x value, 1.5. If you don't remember that, just remember it's where the graph is symmetric, or where the graph, if I were to cut it in half and fold it, it would be exactly the same on both sides. Okay. Yes, x equals 1.5. So for the domain, remember that's the x values from left to right. This graph, it doesn't have arrows, but we can assume it is continuous. So it will begin at negative infinity and continue to positive infinity. For the range, from the lowest point, we start in the depths of the negative infinity and we go up to 4.5. 4.5 is included on the graph. There's no gap, hole, or space, so we're going to have a bracket. All right, any questions? Okay. All right, part C, use the graph to identify key features. So we're going to identify the vertex, but let's pause really quick. We have a graph here that is talking about the height of a ball. It says the x value is time and the y value is height. So it seems as almost this ball could be like, because it starts so low, and it's going up in height. So maybe it's being thrown or bounced off the ground. So it's either being thrown, so it creates a parabola, goes up and down, or it's being shot towards the ground to bounce up and create a parabola again. So we can say that here, ball thrown or bounced off the ground. Because it doesn't start at 0, it starts at like 5. So either someone is 5 foot tall, so maybe it's not being bounced off the ground. If it bounced off the ground, it would have been started at 0, right? So it's starting at 5. So usually people are somewhere around 5 feet tall. So someone around that height is throwing the ball. All right, so our vertex is going to be up here. So we're at 2, and I would guess about 68. It doesn't have to be perfect. We're just practicing what we've used, what we've learned in this class. We can even say this is approximate. All right, and we do have a max here, and we could say the max is about y equals 68. For the zeros, we have nothing from the left because he didn't start from the ground, but we do have 1 0 over here at, let's just guess, about 4 0. Okay, and then we have an axis of symmetry, which is basically our mirror going through x equals 2. Our domain, since we don't go from infinity to infinity, and this is a ball that starts at about 5 feet and ends at about 4 feet, we'll say our domain from left to right starts, and this is the x value, so we're not looking at the y value of 5, we're looking at the x value of 0. So the domain for the x value starts at 0, that is included, so it's going to be a bracket, and it ends at 4. That is included, so it's going to be a bracket. Our range, which is the y values from bottom to top, our lowest y value, well, on this side it starts at 5, but over here it starts at 0. So our lowest y value will be 0, and it continues up until that number approximately 68. All right. Next page, we have some of the Desmos calculator regression practice. We just did this on that quiz. If you remember, you have the calculator, you just type in all the data. This is your x value, your y value. It tells you how to do it on there. You type in the graph. What is the question? It says write the equation. So when we write the equation, you're going to look at the a, b, and c on the calculator and fill in those numbers for a, b, and c on your quadratic regression equation. So you can do this on your own. I'm just not going to put up the calculator on here. And if you need some help with this, definitely please ask me for help. I'll be happy to help you. So you'll take A, B, and C from your calculator and you'll just put it into this equation and then write your equation. What is the approximate time when the rocket reached its maximum height? So here, since height is the y value, you would say, you would look at the graph, wherever its maximum height is, its top y value, and see what the x value is right there. You can even put in an equation, say, okay, our highest y value looks like it was 378. So you could say y equals 378 in the calculator, and then go look at the graph, and it'll have a nice line here. And you could see where they intersect, and that would give you the x value, because that's what we're looking for, maximum height. It says, what is the approximate, yeah, I think I wrote that wrong, sorry. Just catching myself. I said we're looking for the maximum height. We have the maximum height. We would be looking for the approximate time, which is the x value. Wrote it in the wrong spot. Okay, what is the approximate time, x value, when the rocket hit the ground? So we would be looking at the lowest y value, which should be 0. And you would look at the intersection at y equals 0 and see what the x value is there. Okay. If we have time at the end of class today, we can all take out our Chromebooks and try to go over that really quick. All right, next section. Write the equation in all forms for the function below. All right, so it gives us a graph. And it wants us to write these equations in vertex form, intercept form, and standard form. So before we get started, I will tell you what these forms are written like. Oops. So in order to start with our vertex form, we're going to have to look at the vertex of the graph and find our a value. At the top of your page, you should see there that it says a equals rise over run squared. So let's start with the vertex really quick. What is my vertex here? Our vertex goes up to 4 and 2 for the y value. So our vertex is 4, 2. And for our a value, looks like we have a nice clear point right here. If there was a clear point right here, then we would use that one. You want to use the nearest visible point that crosses through the crosshairs of the graph, the coordinate plane. But there is no point there, so we're just going to go to the next point, which happens to be an x-intercept. With these graphs, the next point available is not always the x-intercept. It might be a point before that. So please look at your graph and go down. Like look here and think, oh, where's my next point? Oh, there it is. Okay. Don't just assume that the x-intercept is the next point because there might be a better point. And if you use the x-intercept and there is a better point, you might get your a wrong. So we're looking for the next available point. So for rise, we go down 2 and we go right 1. So we're going to have negative 2 over 1 squared. Well, 1 squared is just 1, and negative 2 divided by 1 is negative 2. So just like that, we can go ahead and start writing our vertex form. We should have y equals a, which is negative 2, x. We have a positive 4 here, so we're going to have negative 4 inside, and we have 2 on the outside. All right. Next section, we want factored intercept form. So for this section, we're going to be looking at the y-intercepts. We have one here at 3, 0, and one here at 5, 0. So in order to write our equation, we're going to use that same a value, which was negative 2. Then we'll have x minus our first one and x minus our second one. Easy enough. Next, we're going to use our completing the square to find our standard form. I'm sorry, not completing the square. We're basically just going to FOIL the factored or intercept form out. So we will say y equals negative 2, x minus 3, x minus 5. And we're just going to use this space out to the right to go ahead and FOIL that out to get our standard form. So we're going to transfer this, sorry. We're not distributing that. We're starting with x times x and then x times negative 5. X times x is x squared. X times negative 5 is negative 5x. Then we'll start with the next number here, negative 3 times x and negative 3 times negative 5. We have negative 3x and positive 15.